what I'm going to do for today, for this quick little video, because there are literally just two examples, you actually already know the first part of Gauss-Jordan elimination, and the first part is Gaussian elimination. So we know that the first part of, or when we use Gaussian elimination, we want to have our, and we're going to, since we're doing our matrices, we're going to take a system, we're going to turn it into an augmented matrix, and we're going to put it in row echelon form. So if you take a look at this first example here, what I want you to do is I want you to take the system, I want you to take this system, I want you to put it into an augmented matrix, and then I want you to put it into row echelon form. So you're going to pause your video, augmented matrix, row echelon form, and then rejoin me in the video. So at this point, you should have a matrix that is in row echelon form. Each one of my leading coefficients is 1. Now, if I was just doing Gaussian elimination, at this point, I could now say that z is equal to 2, and I could back substitute. However, we are going to now start to use Gauss-Jordan elimination. The purpose of using Gauss-Jordan elimination is that you don't do the back substitution. We're going to continue with our row operations so that if you look at the last matrix I have up here, this -2, the 3, and then the other 3, those are, my goal is to get them all to be 0. So I'm going to keep my leading coefficients of 1, and then this -2, 3, and 3, those are going to become zeros. This is what's going to become, we're going to call reduced row echelon form. It basically, this next part of Gauss-Jordan elimination takes the place of back substitution. So I'm going to start off by just rewriting my matrix. Now, you may or may not have a few different numbers, maybe depending on what operations you did, but I think everybody should pretty much have the same matrix. If not, you can just follow along and then you can perform the operations on yours. So my goal is I'm going to work backwards. I'm going to start with the second row. I'm going to make this 3 in the second row. So second row, third column, I'm going to change that into a 0. So I have my first row, which is going to be left alone. And my last row is going to be left alone. So my second row, what I'm going to do is I'm going to do -3 times row 3, and I'm going to add that to row 2, and that's going to replace row 2. So that's going to give me a 0. That's going to keep my 1. So now this would be -3 times 1 is -3 plus 3 is 0. -3 times 2 is -6 plus 5. That's going to give me a -1. So now my goal is to work on the first row. So my second and third rows are all set. Now I'm going to work on the first row. So I think I can squeeze in one more matrix here. So my second and third rows are this, okay, I can leave those alone. So they're not going to change at all. Okay. So let's work on the first row. I'm going to make this -2 into a 0 first. So I can do that by multiplying the second row by 2, adding it to the first row, and that's going to replace row 1. So that would be 1. So that's going to be 2. So that's going to give me my 0. So 2 times 1 and then plus a -2. And then I now have 2 times 0, 0 plus 3. So that's going to give me 3. 2 times -1, so that's -2 plus 9, so that's going to give me 7. In the next step, I'm now going to get rid of this 3. So I'm now going to go down to my row 3, and I'm going to multiply that by -3 and add it to row 1. So I'm going to multiply the third row by -3. I'm going to add it to row 1, and that's going to replace my row 1. So remember, my second and third rows were good, so we're going to keep those the same. Those aren't changing. Okay, so now I'm going to multiply the third row. So that's 0, that's 1, that's 0 plus 0. Okay, so now here's where it's going to change. I have -3 times 1, that's -3 plus 3, that gives me 0. Negative 3 times 2, that's negative 6, plus 7 is going to give me 1. This is now in what we call reduced row echelon form. Okay, now what this does is this has taken the place of back substitution. So I now know all of my variables. So if I look at my first row, x is equal to 1. I look at my second row, y is equal to negative 1. And then I look at my third row, z is equal to 2. So in Gauss-Jordan elimination, you take away that back substitution piece and you continue to do row operations in order to get reduced row echelon form, which will then give you your solutions. So that last step, that reduced row echelon form, that gives you your solutions to each one of your variables. Okay, so what I want you to do in the next one is I want you to go ahead and set up your Gaussian elimination. Okay, so get to your matrix that has a row echelon form, then use row operations to put it into reduced row echelon form, which will then give you your solutions. Okay. All right, so go ahead and pause the video now, and then when you restart the video, I'll have all of my steps worked out. Keep in mind that your steps may be different than mine, but we should still come up with the same answer in the end. All right, I decided to put it in row echelon form first, and then I'll pause the video again, and then I'll do reduced row echelon form, giving the Gauss-Jordan elimination process. So at this point here, if it just said solved by Gaussian elimination, you could get to this point, and then you could say, all right, z is 2, we're going to back substitute, and then you could get your other values. Using the Gauss-Jordan now, I'm going to do some row operations. I'm going to put it in reduced row echelon form and then give my solution. So if you've gotten to this point, go ahead, pause the video, and now use your Gauss-Jordan elimination, put it in reduced row echelon form to get your solutions. So as you can see in the last two matrices, now you could have done this all in one matrix if you wanted to. I could have taken this last matrix. I could have done this 3 times row 3 plus row 1 replaces row 1. That could have been done in one matrix. Okay, so sometimes you can get into row echelon form, and within one step or one matrix, you can have your solution instead of the back substitution. So you should have come up with the answers of x is 1, y is negative 3, z is 2. Okay, so it's just a matter of getting those leading coefficients of 1 and then making all of your other values, working back up your matrix, making those other values 0. So what I want you to do now is now you have a MathXL assignment on Gauss-Jordan elimination, and then you have a quick quiz next class. So it'll be one question solved by Gauss-Jordan elimination. I'll be looking for that row echelon form, that reduced row echelon form, and then your solutions. Okay, I hope you guys have a great day.